All right, so we need to know how to be able to convert penZAC problems. That is, either we are given PEN, we need to find ZAC, or the other kind of problem, put that over real quick, is we are given ZAC, we need to find PEN. So the first thing we have to do is we have to answer the question of what the heck are these things? And it's pretty simple. P is number of protons. E is number of electrons. N is number of neutrons. Right? Those are pretty self-explanatory. We've been talking about the atomic model and the parts of the atom, subatomic particles. What the heck are Z, A, and C? And you're going to notice all three of these are capitalized. These are atomic characteristics. Z is atomic number. And students always ask, they say, hey, why is atomic number Z? Well, it wasn't the first one discovered. The first one discovered was actually A, which is atomic mass. And when they were coming up with abbreviations for these, A was already atomic mass, so they couldn't use A, so they went to the other one. Capital N was taken for something else, that's a Newton, so they went to the German word for number, which is Zeine, and Z-E-I-N-E. And so that is where that Z comes from. C is atomic charge. All right, so atomic number is the easiest one. It is always equal to the number of protons in the atom. Pretty simple. Atomic mass, for atomic mass, there are two things in the atom that have charge. Electrons have not charge, two things that have mass, there we go. Electrons have a mass of next to 0. So we do not include them in atom mass. It's P plus N for atomic mass. And by the way, some folks will call this atomic mass number. I don't like that because we're already using number up here. I just call it atomic mass. Atomic charge, well, there are two things in the atom that have charge. And then there's one thing that has a charge of 0. Neutrons have a charge of 0. So to find atomic charge, you take protons and you subtract electrons. Now, why the heck do you subtract electrons? Well, you got to remember, we've already talked about this, electrons have a negative charge, so that's why we have P minus E for that one. So if we look at problem number 1, problem number 1 says that there are 34 protons, 35 electrons, and 59, holy cow, neutrons. That's a lot of neutrons. All right? So if we know that information, this one is pretty easy. Z is just 34. A, to find A, we're going to have to do some math. We're going to have to do a little bit of algebra. So, actually, no, we're not. I'm sorry. I take that back. I'm getting ahead of myself. Protons plus neutrons to find A. So there are 34 protons, and there are 59 neutrons. So plug it into your calculator, and you get 93 neutrons. Or you can do it in your head. If your calculator, your head gave you something different, you might need to get it examined. Just a recommendation. But I'm not that kind of doctor. Atomic charge is protons minus electrons, so we have 34 protons minus 35 electrons. That gives me an atomic charge of -1. Great. Now let's look at problem number 26. Problem number 26, right? It says that Z equals 72, A equals 198, and C equals 0. So now we have ZAC. We have to go backwards. We have to find PEN. So first one's easy. If Z equals P, P equals Z. I believe that is a property in algebra, right? So since Z equals 72, we have 72 protons. Easy enough. For E, we've got to use some math. We've got to use a little bit of algebra. And we see the only thing we've got here that includes electrons is that atomic charge right there. So what we're going to have to do is there are two ways to do this. I don't really care which way you do this. I'm going to do this two different ways, okay? In one way, we start off with that charge equals P minus E, protons minus electrons, and we plug the numbers in. So we get the charge is equal to 0, protons we now know is equal to 72 minus E. Subtract 72 from both sides. And what this one cancels out. We're left with negative 72 equals negative E. Therefore, E equals 72. Check. If we do our algebra right the other way, we should get the same exact answer. So that's what we're going to do over here. We're going to do it the algebra way. P minus E. We need to get E all by itself. We got to subtract P from both sides. Minus P. That cancels that one out. And we have C minus P equals negative E. So now we got to get rid of the negative sign. So you multiply both sides by a negative 1 times negative 1 times negative 1. There we go. Squeeze that negative 1 in there. And for those of you who may not remember, if we multiply this by negative 1, what it does is flips that thing around. So we get this is P minus C equals E. So now I just plug them in. Protons is 72 right there. Charge is 0 equals E. I get E equals 72. Doesn't matter which way you do it. You get the same answer. Great. So E is 72. For N, we've got to go back up here and we see the only thing with N in it is atomic mass. So we get A equals P plus N. This one I'm just gonna go straight down. And I'm gonna say that A is 198. 198 equals number of protons is 72 plus N. And over here, we can just solve for N. It's really easy to solve for N. All you gotta do is subtract P from both sides. Oops. Sorry about that. That's supposed to be a minus P right there. A minus P on the left. That gets rid of the P right there. Equals N. So A minus P is 198 minus 72 equals N. N equals 126. There's that answer right there. So we're just going to take that. We're going to plug it back in right down here. 126. And that's how you do both types of penZAC problems.